Here's today's daily, and yeah, we will practice with GPT-2 today, and let's get started. Hi, thank you for having me today.
You're welcome. I'm excited to be here. Feel free to start with any clarifications about the problem, and we can go step by step.
Okay, so the question asks us to have a fixed size of fixed size window with size k, and we can use a fixed size sliding window to go through every sub array in the nums array, right? And for each fixed size sliding window, we want to pick the most frequent number for top x frequent number. So if the x is 2, we want to pick the most frequent 2 numbers in this fixed size subarray. And if there is a frequent with a tie, and we pick the largest number. Is that correct?
Yes, you've got it right. We're sliding that fixed window of size k, and for each window, we count the frequency of numbers. Then we take the top x most frequent ones. If there's a tie, the bigger number wins. Let me know if there's anything else you'd like to clarify, or we can move on to discussing how you'd solve it.
Okay, so since that the constraint is pretty small, like the maximum length of the nums array is 50, so I think we can just basically simulate the operation. Do you think that's a good idea?
Yes, that sounds like a good plan. Given the constraints, we can definitely go for a more straightforward approach without worrying about efficiency too much. We can directly count frequencies for each window and pick the top X. Let's move on to discussing the exact approach you would use. How would you keep track of the frequency and then pick the top X elements?
Okay, so I think I'll use a for loop for the fixed size sliding window, and I'll use a hash map to track how many numbers. I mean, the key will be the number, and the value will be the frequency that it shows in the current fixed size sliding window. And then I'll use a min heap with size X, and then for each round we can just push every key value pair into the min heap and and calculate the result and put this result to the final output list. Does that sounds clear?
Yes, that makes a lot of sense. So just to confirm, you'll maintain the frequency map as you slide the window by adding the new element and removing the element that's sliding out, right? And the min heap will help you keep only the top X elements based on frequency, and in case of a tie, the bigger number is considered more frequent. Perfect. Let's move on to coding the solution. Are you ready to start coding?
Yes.
Great. Let's begin. You can start coding whenever you're ready, and I'll follow along.
Okay, so I have finished my code and let me explain to you. So I will have a frequency map and with the default date, and our init should be the integer, and I will also have a variable n, and which is the length of the nums array, and I will have a result list, and this would be used to store the final result. And I will use a for loop, start from 0 to n, and I will make the current number add to the frequency map, increase the value by 1, and I will have a condition. So if the current index is larger than k minus 1, which means the current window is valid, then I will start to check the current result and remove the left element. After that, I getting the current result. And for getting the current result, I implement a getX function, and in this function, I initialize a min heap, and I will go through the frequency map for key and value, and I will push the value key pair into the main heap. And value stands for the frequency, and the key stands for the actual number. And in each round, if the current min heap length is larger than k, and we will do the heap pop. And after looping every key value pair in the frequency map, I will use a single for loop and to add the key value pair product into the current variables and return the current variables, and this will be our result for this fixed size sliding window. And after that, we will append this value into the result list. Does that sound clear to you?
Yes, that explanation is super clear. So just to recap, you've got your frequency map, and when the window is valid, you call that getX function, which uses a min heap to find the top X elements, and then you sum them up, and yes, you're popping from the heap to keep it at size X. Perfect. I love how you're removing the left element when sliding a window. That's all very clear. Let's do a dry run now. Could you walk me through an example using this approach?
Sure.
Awesome. Let's go through it step by step. You can pick one of the examples and let's run through how your code processes each window.
Okay, so then I'll use the nums array with 3, 8, 7, 8, 7, 5, and k equals to 2, x equals to 2. I will use this example to do some dry run.
Perfect. Let's start from the beginning with the first window. Walk me through how you calculate the x sum for each subarray, and we'll do it step by step.
Okay, sure. So let's start from the for loop at line 19. So we will do the for loop for each position in the nums array. So the first one is 3, it comes in, and we will add the frequency map, and the key value, the key is equals to 3, and the value plus by 1. So we got a new hash map, the frequency map with key 3 and value 1. And because the index is not bigger than k subtract 1, which is 1, so we just skip this round, and then we will go to the next round. Next round is 8, next round is 8, and 8 comes in, so we add the key value pair into the frequency map, and the key is 8, value is 1, and since that the current window is valid because the index 1 is larger than k subtract 1, it is equal to k subtract 1, so we want to do the get x, and in this function we initialize that min heap as an empty array, and we go through the key value pair. So we store the min heap as like 1 and 3 pair, and also 1 and 8 pair. And since that the total array is smaller than the size of the total min heap is smaller than x, so we didn't pop anything out, and then we just go through each value and sum them up, and return the current would be 3 plus 8, and that would be 11, and we will append this 11 into the result list. And after that, we want to remove the leftmost value from the hash map, so we will decrease 3 by 1, and yeah, and so the value map will be 3 with 0 frequency, and we get 8 with 1 frequency, and then we will go to the next round and we will do the same thing, and so on. So basically this is how my code works. Does that sound good to you?
Yes, that sounds great. You walked through that really well. For the first window, you got 11, and I see how you remove the leftmost element as you slide the window forward. That's perfect. Everything makes sense. Let's now run through the rest of the subarrays. After that, we can move on to complexity analysis.
Okay, yeah, so should I do a full dry run for the rest of the array, or I just do one more?
Just one more should be fine. That way we can make sure everything's clear, and then we can move on to the complexity. Go ahead with the next window.
Okay, so the next value inside will be 7, and since the hash map has been already updated to 3081, and for current value is 7, and we want to increase the frequency by 1, so it will be 7 and 1, and the window is valid, so we go to the get x, and in this round we will append every KV pair into the min heap. So we actually got 0, 3, and 1, 8, and 1, 7. And since that the frequency is the first element of the pair, and we use the min heap, so it should be at the top of the min heap, and the current min heap array is larger than the x2, so we want to pop out the first one value in the min heap, so the 0, 3 pair would be pop out, and then the remaining value would be 1, 8, 1, 7, and then we will sum that up, so that would be 8 plus 7, which is 15, and then we return this 15 to the we will return this 15, and then we will append this to the result array. And after that, we want to update the update the frequency map. We want to remove the leftmost, and the current leftmost is 8, so we decrease 8 by 1, and our new frequency map will be 3 with 0, 8 with 0, and 7 with 1, and then we can go to the next window.
Perfect. That was a really clear dry run. I can see how the logic works now. Great job. Let's move on to complexity analysis next. Can you walk me through the time and space complexity of your solution?
Yeah, sure. So I think we can start from space complexity because this is kind of simple. So for space complexity, I think that would be the size of the frequency map, or okay, we used three data structure. We use a frequency map, and we use a result list, and we use a mean heap. Okay, and so for frequency map, I think the length, the space the space we use would be the length of the nums in the worst case, and for the result, that would be the length of nums array divided by the k, I think. Oh, not divided by k. Will be the length of nums subtract k, and for min heap, that would be of x, and x is the maximum length of the min heap. So I think overall, the worst space would be the length of the frequency map, and which is the length of n, which is the length of the nums array. And so I could say the space complexity is O of n. And for time complexity, we use a single for loop to loop every window in the nums array. So that would be O of n. And in each for loop, we use a get x function. And in this get x function, we use a min heap. And the min heap size is x. So I would say for space complexity, for time complexity, that would be n squared times log x. And yeah, because we need to for loop each frequency map, and we also need to do the heap push and heap pop from the min heap, and the min heap size is of x. So yeah, for total time complexity would be of n squared times log x.
Great, that makes perfect sense. The space complexity is On because of the frequency map, and we store the result, which is also proportional to n, and the heap size is at most x, which is small compared to n. For time complexity, we loop over each window, and for each window, we process the frequency map, which can have up to On elements, and each heap operation is O log x, so yes, On squared log x is correct. That's a solid analysis. Anything else you'd like to cover, or any questions about your solution?
Yeah, I have no more question. And just to wrap up, could you give me a grade for my performance, or any suggestions for my interview skills or anything?
Absolutely. You did a great job. I'd give you a solid 4.5 out of 5. You clarified the problem well, had a clear approach, and walked through everything step by step. One suggestion would be to keep an eye on time complexity early and think about optimizations if needed, but given the constraints here, your solution is great. Keep practicing explaining your thoughts as clearly as you did, and you'll be perfect. Well done.